take a look at our potential and kinetic energy notes here and go through them. First, we're going to talk about potential energy. And potential energy is energy that does not have motion. It's energy that is stored. It is energy that is always measured relative to the height that things are. So that's important for you to know. So it's always measured in reference level from which the height is measured. So that you need to know that for their test. There are different forms of potential energy, and some examples of those are chemical, elastical, gravitational. An example of chemical energy is gasoline. The bonds in the gasoline chemical makeup stores energy, is released when the combustion occurs. Another type is elastic potential energy. These are things like if I have a rubber band and I stretch it out, those wind-up toys that as you turn it, and then it pops up. That's an example of elastic potential energy. If you take a basketball and you just really push it in, if it doesn't have all the air in it, you push it in and it bounces back out. That's potential elastic energy. So those are some examples of those. You need to know examples of different types of potential energy for the test. Examples are bonds of glucose, energy of a stretched rubber band, and know that G is the acceleration due to gravity for potential energy, because the formula for potential energy is mass times gravity times height. And so this is why it is relative to the height that is measured. The higher up you are, the more potential energy you have. Also, if I increase my mass, I'm going to increase my potential energy. Gravity is always the same. It is a constant. It is 9.8 meters per second squared is what the acceleration of gravity is on Earth. The second type of energy that we need to know is kinetic energy, and you need to know some examples of kinetic energy also. You need to be able to look at a situation and you need to be able to say that's kinetic energy or that's potential energy. And kinetic energy is the energy of motion. So all objects have kinetic energy because the molecules that make them up are always moving. They never stop. Even in a solid, and we'll talk about this in our next chapter, even in a solid, the molecules are really close together, but they are still moving. They're vibrating back and forth. It is relative to its mass and its velocity squared. So the formula for kinetic energy is 1/2 mass times velocity squared. So it is proportional to the square of its velocity. So if I increase my velocity, I'm going to increase my kinetic energy by a great deal because I'm squaring it, even though I'm taking half of it. So you need to know how that formula is relative to each other. You need to be able to look at a roller coaster graph, and you need to be able to tell where's the most potential energy, where's the most kinetic energy, where's the least of each. You're also going to have to look at a diagram that shows a ball bouncing. We put it up hold it up, you bounce it on the ground, it bounces back up, bounces back down, bounces up, down. And you're going to have to look at that pattern and tell where is the most potential energy and where's the most kinetic energy for that, so that you know that that will be on the test. Conservation of energy is a law, and it states that energy cannot be created, it cannot be destroyed, but it can be transferred from one form to the other. So we can convert it from one form to another, right? And so kind of know some examples of that. We know with all of our things that we've been doing that kinetic energy gets transferred to potential energy and vice versa. And know that whatever joules that I start with, that is what I need to end up with. We know that joules is the unit for energy, capital J, Joules. Need to know that. So here we go. Here we have our roller coaster scenario, and you need to know where the most kinetic energy is and the most potential energy. So your most potential energy is going to be at your highest hill, because we know that that is where potential energy is measured in relationship to its highest point measured. So the highest point there would have the most potential energy. the most kinetic energy is going to be right at the bottom of your hills there. So you need to know that. So review some roller coaster scenarios and know where the most and the least amount of potential energy is, most and least amount of kinetic energy. So we need to know speed versus acceleration here. So remember, speed is distance divided by time. And then we added to our notes, correct? We added to our notes the other day that velocity is speed with direction, correct? And we said that acceleration is when we change our speed and direction. All right? So there's examples of the differences. Velocity is I'm going down Route 60, doing 60 miles an hour due north. Velocity gives me my speed and direction. Acceleration changes my speed and direction. So for example, I could be on a racetrack going round and round and round, and my speed is the same, but my acceleration is changing because I'm changing my direction all the time. So that's our difference between speed versus acceleration and velocity. So make sure you have that change in your notes. We did it in class so that you know. So now let's look at our average speed graphs. So our speed one on our left side is a cyclist. They're going at a constant rate. And so you can tell that because the line is a straight line going up. So they're increasing their speed because speed is distance divided by time. They're increasing their speed because the line is going up at a constant rate. Our roller coaster, on the other hand, we have from 0 to 2 seconds, we have an increase at a constant rate, and then we kind of have a stoppage for 1 second there. And what is that stoppage from? You know, the stoppage is as you're going up that hill and you're increasing, and then you get at that top of that hill, right before you come down, you got that 1 second before you stop, before you go back down the hill. But whenever you have a straight, flat line like that, a horizontal line, the line that is parallel with the horizon, then that means that you have no movement. Your distance has not changed at all. Time could elapse, but for some reason you're at that one point for so much time. And then if you notice again, we go up at a pretty fast rate because that is a steep line. And then the third line that you have there, you're going at a constant rate similar to the initial constant rate, but not quite as quickly as the time between 3 and 4. The steeper the slope, the faster you're going to be going down. So if I'm going to calculate my average speed, I'm going to take my distance that I traveled over the whole period of time divided by my time, and that will give me my average speed. Know that on the test, you need to be able to calculate speed at certain times, at certain intervals. You may have to calculate average speed, so you're going to need to be able to do that. And you need to know that you have to make sure that you have the right units on the documents. All right? So now you're going to have a scenario like this, and you're going to need to know what's going on. So between A and B, I have a nice constant increase. Between B and C, I'm stopped. I got nothing going on. Between C and D, I'm increasing my rate, but I am doing it at a pretty fast clip, faster than going from A to B because it's a steeper line. Between D and E, again, we are stopped and we have no movement. Between D and E and F at the end there, you are decelerating at a fairly quick rate because the line is fairly steep. So that's what's going on in that graph. So you have to be able to look at graphs for the test, and you need to be able to tell what's going on at each section. All right, there you go. There are your notes for this unit.